This is a linear programming problem from section 7.3 in our textbook, number 13. Hey, our principal, Mike May, he made the textbook. Pretty cool. Anyway, in this problem, we had a system of inequalities that are constraints, and we're trying to maximize or minimize something. In this case, minimize his daily cost. He's trying to buy vitamins, and he knows what he wants in terms of vitamin A, vitamin B1, and vitamin C. And so he's trying to figure out, he's got a couple different pills he's looking at to get those vitamins, and they have different costs. So when you're looking at this, and I'd invite you, if you're watching this later, to pause the video at any point if you think you know what to do, and try it yourself before you hear me say it. Anyway, the first thing I would do is try to identify your variables. So I'm going to use two variables for this, x and y. And for one thing, we know these are all going to be two variable systems because we're graphing, and we're just going to be doing two-dimensional graphing. So, but also, if you're trying to figure out what your variables should be and how many there are, read the question. How many pills of each brand should he buy? That's the question. So to minimize daily cost. The brands are brand Z and brand X. And so those are what I'm going to use here. Brand X will be X, number of brand X pills. And brand Z will be Y. That'll be the number of brand Z pills. Brand Z. I'll say number. It's the number of pills. All right. And if you want to figure out next the objective function, right? That's the thing we're trying to maximize or minimize. That's what I would do next. Again, if you think you know what to do, take a pause, read it, make sure you have an idea. And in this case, we're trying to minimize daily cost. So that is going to be our objective function. Z is going to be the daily cost. And here it is. The brand X pills are 15 cents. The brand Z pills are 30 cents. And so it's going to be 0.15 times X, the number of brand X pills, plus 0.30 times Y, the number of brand Z pills, right? So that's my objective function. And I would say I'm just going to write minimize here. I think that's a good idea to write what you're trying to do. Some questions in the book have said minimize and maximize. In this case, we're trying to minimize. Okay. The next piece of this is to write down our constraints. So they'll say subject to. And so what we're going to do is we're going to write down the constraints here. And the constraints are the different needs, right? So he needs 16 units of vitamin A, he needs 5 units of vitamin B1, and he needs 20 units of vitamin C, at least. He can have more. It's okay to have more. So if you look at brand X has 8 units of vitamin A. And if you look at brand Z has 2 units of A. So you're going to have 8x plus 2y for vitamin A. I'm going to put A here. And A has to get to at least 16. So that's got to be greater than or equal to 16. If you think you got the idea now, maybe pause and try the other ones. I'm going to do a B1 and a C constraint. So for B1, brand X has 1 of B1, and so does brand Z. So 1x plus 1y is going to be greater than or equal to, and this one's 5 if you look. He needs 5 units of vitamin B1. And then vitamin C, same idea here. Brand X has 2 of vitamin C. Brand Z has 7 of vitamin C. So 2x plus 7y is greater than or equal to, and in this case, he is supposed to have 20 units of vitamin C, so greater than or equal to 20. And then two more little constraints. He can't take a negative number of pills. So X and Y are both greater than or equal to 0. And those are going to be the constraints. I'll make a separate video finishing the problem.